Heyo, we are here. Oh my goodness. What is going on, everyone? Welcome to our second edition of the Vector Space Talks. Look at that. There's celebrations already happening because this is about to be a really cool event. We've got two speakers today, and the first one was a bit of a special guest announcement. We threw them in last minute because they had a big announcement over the past couple weeks. And so we've got Nils coming on, going to be talking about Cohere's embedding model. We've also got Philip coming on later to talk about music and AI and all kinds of fun stuff that he's done with Quadrant. So I cannot wait. Hopefully, you all cannot wait. Let us know, get active in the chat. That's probably the best part about watching this stuff live. Ask us questions. Let us know if things are resonating with you or not. And I'll be monitoring it so that you can ask any kind of question you may have. And I can jump in and ask Nils if it warrants a stop in his presentation, or we can ask him at the end and we can have a little bit of discussion. So I think the first talk is going to be about 10 minutes, 10, 15 minutes, and then we got 10 minutes planned for Q&A. Without further ado, I've got my man Nils around. Where's he at? There he is. Hey.
Great. Thank you for being here and also inviting me last minute. I have two technical topics today, I think, which will be really interesting for anyone in the embedding space, which also work really well with Qdrant as vector database. Happy to talk more on this and show
Dude,
people more on like embeddings and what's going on, what's the newest innovation in the space.
it's all about the embeddings, baby. So I'm going to kick it off to you. I will share your screen real fast and I'll get out of the way. And I look forward to hearing about this. It's super exciting news. So here we go, man.
Oh, great. As mentioned, we launched last week the version 3 of our embedding models. It was a really cool project. A lot of the team has been working on really get positive from beta testers so that we said make it public. On the one side, it's a state-of-the-art model in 100 languages on different well-known benchmarks like the massive text embedding benchmark or the information retrieval benchmark BEIR. But here I want to talk a bit more on like two interesting critical model innovations. One is like content quality estimation, and the other is compression-aware training. So in embeddings, for a really, really long time, embeddings were mostly measuring the topic match. So you have a query and you have a document and you want to know how similar are these on the topic. But in information retrieval and search, you not only care about like, is it on the same topic, but which document is the most informative. So for example, let's say you have a collection of documents. COVID-19 has many symptoms. COVID-19 symptoms are bad. COVID-19 symptoms are not nice. And then you have two documents, paragraphs. COVID-19 is a disease caused by a virus. The most common symptoms are fever. COVID-19 symptoms can include. And then you have at the end one about dementia, that it has the following symptoms. And here you quickly notice, so if you have a collection like this and you run a query, a search query, hey, what are the COVID-19 symptoms? And you take a model, for example, from OpenAI or from sentence transformers, and just measures topic similarity. The top three results will be COVID-19 has many symptoms, COVID-19 symptoms are not nice, COVID-19 symptoms are bad. So obviously, if you show this on the left to a user and they say, yeah, that's interesting that COVID-19 has many symptoms and that they are not nice, but it's not really, really informative. And many people now use these embeddings also in these retrieval augmented generation RAG, where you ask the RAG model, hey, write about this. And then the generate model can only say, okay, it has many symptoms and the symptoms are not nice. But it leaves like a really bad feeling to the user. In contrast, on the right, what do we see? A model that measures content quality also. It retrieves the most informative first. So it says, okay, this document is the most informative. It provides you detailed information about COVID-19 symptoms. This is also providing detailed information on COVID-19 symptoms. And the last one, yeah, it's on COVID-19, but has not really detailed information on it. And so it makes a really big difference if you work on larger quantities of data. So at Cohere, we're focusing heavily on these big use cases where you want to have search over like a lot of data. And then if you have a lot of data, you often have like content that's not really informative and content that's really informative. And here the model is able to differentiate what's informative and what's not informative. And how to do it. So a big challenge is that previous models, many models and many training pipelines, they just measure topic. So they look at the query, they measure topic similarity, and then they just decide on the topic similarity. And if you look at these two documents, so if your query is COVID-19 symptoms and document A is COVID-19 has many symptoms, document B is COVID-19 is a disease caused by a virus, the most common symptoms are, and then many more and more words on the symptoms, you see that the topic similarity of query and document A is higher than the topic similarity of query and B, because document B is not only on symptoms, it's also on that it's caused by a virus. So it's not that good on a topic similarity, but obviously we, as human too, we like more informative answers. So we like the one which provides us background information, and also for RAG, it provides we like the more informative information, the more informative paragraphs and documents, and we want to have these. And so what we do in the new model is to measure topic match and content quality. So you can think about a simplification of it is you think about a certain set of dimensions, measure the topic match. So how similar is the query and the document on a topic? Are both talking about COVID-19 symptoms? And then a fraction of the dimensions talk about content quality. And what you could do, for example, in the setup, so you have a query encoder. So here it becomes critical that you have two different encoders. Query encoder that encodes your query as first dimension is 1, and then the other dimension you encode the topic. And then you have a document encoder that measures the quality of the document and the topic of the document. And then if you compute the dot product here in this case, is okay, the final result is like 1, so the one from the query times the dimensions on the quality from document plus the similarity of the query and the document on the topic. So it's measuring the quality and the topic. In reality, we let the model learn how to encode topic and content quality in the space. So we don't say, okay, dimension 1, 2, 3 are on content quality, but we let the model figure out itself how to train these. And as mentioned, it makes big difference on many scenarios. So Track COVID is a nice example data set on COVID-19 scientific papers from a web crawl, really noisy, many challenges what you have with web crawl, that data is incomplete and missing and not correctly extracted. So here we see a big boost. Another interesting data set is on Hotpot QA, which is a multi-op question answering data set from Wikipedia, where it's also helping a lot to find the documents that are most informative on your query to answer the query. So content quality is not just measuring the text length, but also how much information is on a topic. So you could say, okay, you could sort these just by text length, but here we added like some examples in it, like COVID-19 has many symptoms, and now I add some text without a lot of meaning, just to see if the model only depends on context length or on quality. And here's also like something which is like really short on COVID-19 symptoms, but then I provide some information on my cat. So here we see, okay, the model says, okay, these two, I don't like them. It's still on COVID-19, so it's better than the document on dementia, but it's like worse than the short one and worse than the one that has a lot of information on topic. So it's a really cool feature. I think people really like it if you have these scenarios where you have like a lot of redundancy in your corpus and the content quality is like really different. It has limitations, factual correctness. It cannot reliably differentiate between true and fake statements. So it's not designed for that. It's in general a really hard problem to detect these fake statements and to solve it. It can do it to some degree when it's part of the pre-training data set. So if I ask like COVID-19 symptoms and I have to text COVID-19 symptoms, coughing and memory loss, the model knows, okay, it's COVID-19 is stronger connected to coughing, but it's not reliable. Also, temporal aspects are a challenge. So it cannot differentiate if a statement is still true. If you say, okay, there are no COVID-19 vaccines and there are several COVID-19 vaccines, the model, both can be true depending on the time when the statement was made, but the model is not able to resolve this. And obviously, it cannot solve the trustworthy of a source. So it's the information from the CDC, or does some random person on Twitter wrote this? So it's obviously not perfect. These aspects are also really, really critical. But we're going in the direction where we also want to tackle it. But so far, just on a text level, it's working very well. In terms of training, bit of like challenges in training. So common way to train these embedding models is constructive training, where you say, okay, you take a batch with queries and answers. Issue is here that you just have like one document in it that's on the topic and that's relevant. So here you have like 3 things, and then you say COVID-19 symptoms. Out of the 3 answers, which one is correct? But it doesn't differentiate between any rankings. So what we did is take queries. So we got like millions of queries and retrieve top K documents, all documents relevant on it, and then ask a large content quality model what's the preference. So it's basically preference learning for embeddings. Out of these 3 documents, what's the preference? And then from the model, we know, okay, document 2 is preferred over document 1, is preferred over document 3. And then backprop this to the embedding model, and we say, okay, give us document 2 over document 1 over document 3. The other aspect, which we're going to announce soon, so here you get a short sneak, compression training. Why compression? So the challenge, if you have a billion float embeddings and you run Qdrant, you host it yourself on AWS, it becomes really, really expensive. So if you have like 1,500 dimensions, you need like 6 terabytes of memory per instance. You add some redundancy to it. You look at your EC2 instance price at the end, and it hits you with like $500,000. One way to reduce this is to go to like fewer dimensions. So if you use an embedding model with like 384, it goes from like $500,000 to like close to 200K per year. But still, 200K per year, that's quite expensive. And it's really preventing, because a billion embeddings, that's not so much. So many of our customers hitting in this range, in the billion range. Qdrant on Twitter, or on X, probably also. I mean, Twitter has like 500 million tweets, or used to have 500 million tweets a day. So every second day they have like a 2 billion tweets per day. So it becomes like really, really expensive to run the vector database. So what we need to do is reduce the memory footprint. And here compression helps to reduce it 10 times, 100 times, 1,000 times. And then at the same time, your cost for EC2 reduces. One cool feature in Qdrant is these binary embeddings. It's 32 times smaller, 40 times faster. It's a simple binarization. If the float value is bigger than 0, set it the bit to 1, else set it to 0. And then you operate in this binary space. However, the question is, how well do embedding models support binarization? And the quality of the binarization depends on the model. So if you have a model which looks like this, produces embeddings, they are all up here. If you binarize it, all these 4 embeddings are squashed to the same binary embedding. And then the model performs really badly. So if you take an open source model, E5, nice model, if you work in a float, it runs at a comparable performance as our Cohere model. But if you do the binarization, you see, okay, you get like a 40% drop in search quality. While if the model is trained with compression aware, you just get like 8%. search quality drop. And so this really enables to get these compressions in and say, okay, maybe for my application, 92%, that's good enough for my use case. But the 62% of search quality, that's maybe too bad. And what does compression-aware training do? So instead of like squashing all these embeddings in these tiny subspace, the vector space becomes kind of like nice and nice for these binarizations. So in this case, we would blow it up, make sure that the embeddings are nicely sorted over these different sections, and then you can run compression nicely on it. The other aspect also in Qgrant is these product quantization. Basically, what you do in product quantization, you take the dimensions, you put it into subgroups, and then in each subgroup, you create a cluster. So here we have 2 dimensions. For every dimension, you create 4 clusters. And then at the end, if you take the combination, you have 16 clusters. And the issue here is, again, for the vector space, we see some clusters here around here where a lot of black dots, a lot of embeddings are, and down here is only like a single one, so it's imbalanced. And this is like really, really hurting the cluster performance. And here again, we do compression-aware training. So to make the model really aware of these compression techniques, so that not all the embeddings, that we don't have like high density here and a low density here, but in the best case, an equal density in all these cluster points. And this again makes a big difference. So if we run like 64x compression with an open source model E5, which was not trained for it, we see we lose like half of the search quality. So search quality becomes like really, really bad at this compression. And with compression-aware training, you can keep most of the search quality. And yes, so this like two aspects we did, especially for these large scale deployments. Content quality, it's critical for any noisy data set. So as soon as you have a noisy data set, you will see a big difference. If you have a perfectly nice, clean data set without any redundant information, then content quality is not that critical. But as soon as you hit some scale, you have redundant information with different quality levels, and you want to serve as the most informative. Again, at scale, compression-aware training is critical. It allows you to lower your memory footprint of Qgrant, which reduces the cost on AWS, on your cloud provider. So that's nice if you can search on more data and pay less and still have a good quality. You can use the model either via our API, so you pay per byte token of 0.001 cent or dollar per 1,000 tokens, deployed on SageMaker. So we're big on like private deployments where we bring it to your cluster, or you check it out on SageMaker or AWS Bedrock, where you get it in your VPC, highly optimized, so 5 millisecond latency. And then you get like a really good performant embedding model and combine it with a great vector database like Qgrant. That's so much from my side.
Dude, very good stuff. I really like this, and I have so many questions. I saw there's some questions coming through in the chat too. So while people are asking their questions in the chat, I have to ask you, can you talk to me more about this content quality model? What is that?
Yeah, sure. So basically, it's a bit inspired from this reinforcement learning from human feedback. So in generative models, it's a trick we're using for quite a long time for any generative model, where we say, okay, this is prompt, write me about COVID-19 symptoms. And then the model generates either response 1, COVID-19 has many symptoms, or response 2, COVID-19 is a disease caused by a virus. And then in this reinforcement learning from human feedback, we ask humans, hey, this was your task. Which of these 2 documents is more informative? And then you learn a model on it. So that the model learns, okay, this is a preference. If this is a question, that's the response. And we took this model and brought it back to these embedding training that we say, okay, here we have these preference data. If you search for this information, what do humans prefer? The model can estimate it, and then we throw it at the model. So we take like millions of queries, show them several documents, say, okay, here's a document A on this, here's a document B on this. The content quality says, okay, I think document A is better than document B. And then we check in the vector space, is the similarity of query of document 2 better than or higher than the similarity of query in document 1. So it's basically taking these preference learning back to embeddings.
I love it, man. Yeah, it's so good and it's so interesting to think about. I mean, the uh the use for that and the benefits that you can have from that. So, hats off to you. Now I'm going to start asking some questions from the chat. We've got one coming through that's asking from Andre V. Is it possible to evaluate quality of the embeddings, garbage or meaningful, just by looking at the vector itself without the relative comparison?
No. So it's a mistake people often do. They look at the embeddings. Sometimes they look at the cosine similarity scores. Is it like
Yeah.
60? Like in this case, here we get like a similarity of like 0.72 and then try to estimate on this. But embeddings, it's always about these relatives. I mean, I could just multiply the score by 2 or divide it by 2 or do whatever, add 0.1 to it. It's always about these relatives. Like, is this more similar than this? And is the ranking we get here doesn't make sense at the end?
Yeah. Okay. Good to know. So Renee's asking one in the chat, and this is a little bit Langchain specific. He's saying, as far as I know, the new embeddings need a parameter input type. So far, that is not supported by langchain.embeddings.cohere.cohere embeddings. Will that be
Yeah,
fixed? And
yeah,
when? Or is there a hack that we can do, some kind of workaround?
yeah. We're working on it to get it into Langchain. The input type is critical because we need these differentiations. So it's critical that the model know, is it the query or is it the document? So that it can say, if it's a query, I search for content quality for documents with the highest content quality. So we're basically disabling these dimensions if it's a query. We set them to 1, so that it's just defined by the quality of the document. Because obviously it doesn't make sense to judge a user, hey, did you write a good query or a bad query? But it makes sense to judge it on the document. And yeah, we're working on it into these partners like Langchain, that you soon can use it. Workaround for now is, yeah, just use the embeddings directly without Langchain. Yeah, but hopefully soon it's also in Langchain.
Awesome. Excellent, man. Well, Niels, dude, it has been an absolute pleasure. I appreciate you coming on here as always. This is incredible to hear about what you all are doing and how you're doing it. I also really appreciate that you pulled back the curtain a little bit. You got to show us how you've been creating the special sauce. And so hopefully everybody can get out there and start using this embeddings and yeah, stress test them, try and break things, do whatever they can, and dude, and I hope to see you around Frankfurt sometime. I'm still trying to get you to come and present at the local meetup, so we'll talk
Yeah,
offline about that one, huh?
sounds great. Great for having me here.